Good morning, friends. How are you all? I am Soso. Today I'll discuss the locomotive 110 volt DC control circuit. Already you know that our locomotive is a high powered circuit and its switches, its contactor, everything you if you want to close, you cannot do it directly because this high power system will affect your body, means may cause your end of life, so it is very dangerous. So we are using control circuit with 110 volt DC, which is safe. So today I'll discuss this thing. In control circuit we are using two sets of contact. One is normally closed means when the magnet is de-energized, at that time which contact is in closed condition, that is normally closed, and in energized condition which contact will close, that is normally open. That means in de-energized condition, if it is in open condition, it is normally open, and energized condition, if it is de-energized condition, it is in open condition, it is normally open, and in de-energized condition which contact is closed, that is normally closed. The main thing is de-energized condition. In de-energized condition, which contact is in closed position, that is normally closed, and in de-energized condition which contact is normally open, that is normally open. But when the magnet will be energized, this normally open contact will be closed. So these two type of contacts we are using. I have shown in the drawing these two type of contacts, and this is shown in this way. Now how it operates, I'll show you. Let's see. Friends, in the picture both the contacts electromagnet is in de-energized condition, and in this de-energized condition one contact is closed, that is normally closed, and one contact is open, that is normally open. Now see, if I energize the normally closed contact magnet, it will open, and if I energize the normally open contact, then it will be closed. And this sequence we are using just like binary system, 0 and 1. So see how we are doing it. Okay. So you have seen, when the normally closed contact electromagnet energized, that means it has become red in color, then the normally closed contact has opened. So this is the system. Friends, the question is, then what is the function of normally closed and normally open? You see, these contacts when closed is making through the path of positive to the negative terminal. That means to complete a circuit, when the contact will be closed, it will continue a circuit, close a circuit, and when it will open a circuit. This is the use of these two types of contact, normally closed and normally open. Friends, for an example, the use of this contact, I'll show you a normally open contact when it will make, how it extends the DC positive and tipping a circuit breaker. So here in the picture, what we are doing against a relay normally open contact, in one contact we are giving DC positive, and in the circuit breaker tip coil that has been shown in green color in the circuit breaker, the negative is permanently given. But when a fault will occur, the CT secondary is shown in green color also. The current will pass the relay, and relay setting due to this fault will attract the normally open contact. The coil will be energized of the relay coil and bridge the two contacts, normally open contacts, and DC positive will be extended to the trip coil of the circuit breaker, and one end is positive, another end is permanently given negative of the CB trip coil. So the coil will be energized and the circuit breaker will open. Circuit breaker will open and making the circuit dead. During any fault, the circuit breaker will live. This is the use of this contact. We are extending DC positive in TRD system, and in local control circuit also we are extending the DC positive to make a circuit, and when opening it, it will break a circuit. Here the overload the relay coil is making to break the contact of the circuit breaker. So we are using frequently this normally open and normally closed contact. Thank you, friends. Good morning, friends. How are you all? I am so. In the picture, I have shown you how to close the locomotive circuit breaker. But so locomotive circuit breaker is in 25 kV side. But with the use of this 110 volt DC, we are closing it. How? See, a relay is having number of contacts, some normally closed contact and some normally open contact. And with the use of this normally closed and normally open contact in DC 110 volt system, we are closing the circuit, locomotive circuit breaker. How? First, you close the battery switch, that is HBA. H stands for switches. H stands for BA for battery. HBA, close this switch. Then your DC positive and negative side will be in circuit. Okay, battery switch on. Battery switch on. Now what will happen? We have provided some fuses. We have provided some fuses like CHBA. CHBA is battery charger fuse. Battery charger fuse. CCPT, pantograph fuse, and then CCDJ, fuse for DJ circuit. Okay, this control circuit, all fuses in the control circuit to stop the operation in the power circuit. If it fails, this it will not act. This fuse will melt, then it will not act. Now what will happen? First, when you have energized the close the battery, then immediately you see Q45 will be energized. How? Through this in your second mass, through this CCDJ. BP1 DJ is a spring switch. You close it, then BLDJ. Sorry, BP1 DJ for tripping the DJ. It is in normally in closed condition. It is a normally closed contact switch. Normally closed. NC's contact. It will be in closed condition. Then BLDJ. BLDJ is a divert death switch. You close it. Then ZPT. ZPT is for the selection of pantograph, front panto or rear panto. So it will be in one position. So it will be in closed condition. Then BLRDJ. BLRDJ is a spring switch. driver press it, and then after a few seconds it release it. So this path is also complete. Then GR close on 0. Our traction motor voltage changeover, this we are doing with this graduator, tap to tap of transformer we are changing it. So it will be in close condition before charging the circuit breaker. Then your Q45 will be energized. Your Q45 will be energized. Then what will happen? In the first branch, Q45 is in closed condition. Then your Q118, it is also in closed condition. Why? You see the last branch, your C118, it is in normally closed contact. Then so many normally closed contact like C105, C106, C107, Q44, it will come. Then normally closed contact Q46. Then your GR close on 0 to 5. 0 to 5, you see that it will be in closed condition, so it will come, and Q118 will be energized. Q118 will be energized. After Q118 will be energizing, your Q44 will be energized. When Q44 will be energized, it will close the normally open contact on EFDJ and MTDJ branch. On the EFDJ MTDJ top, there is Q44 contact. Then on the MTDJ, so many normally closed contacts are there, so the DC positive will come and energize the MTDJ. And from this branch, again you see it will go and C118 in closed condition, DJ normally closed condition, now DJ is in open condition, so EFDJ will be energized. When EFDJ will be energized, your circuit breaker will be closed. This is for closing the circuit breaker, this EFDJ relay. Your circuit breaker, your circuit breaker will be closed, so DJ is closed. In this way, I can tell you step by step all the sequence. But today, up to this, my exam is will start soon, class assignment, so I cannot tell today too much more. Be happy and enjoy it.